All right, guys, I just wanted to do a quick video where I show you that your formula sheet has had a bunch of this stuff on it this whole time, and it probably just looked a little funny. So the arrow over the thing says it's a vector. These straight lines mean it's talking about the length of the vector. Notice the normal force is totally not in the same direction as the friction force, but the friction force is generally less than or equal to the coefficient of friction times the normal force. We've also got our dot product here, because if you think about it, this is basically work is force times distance, or force times displacement. But what matters is the component of the force in the direction of displacement. So it's sort of like force times displacement times cos theta, which is encapsulated with this dot product because that's equivalent. But yeah, this is sort of component version. With the power is force times velocity, we've got a dot product because what matters is the component of the force in the direction of the velocity. We also have a bunch of this cross products here. So right here we've got a cross product. Torque is equal to the sort of distance away from the axis of rotation crossed with the force. And if you think about it, we've been doing force times distance times sine theta, and the magnitude of your cross product is the magnitude of one times the magnitude of the other times sine theta, the angle between them. So we've had that the whole time as well. And another interesting thing, we didn't go into it much, but the direction of torque and like angular velocity and angular momentum and all that is considered to, it's done with the right hand rule. So if it's rotating like this, you got your right hand, your fingers are curling in the direction it's rotating, and your thumb is the direction that that torque is considered to be, which is kind of weird. But if you think about it, if something's rotating, it's hard to give it a direction. The easiest way to give it a direction is kind of like coming straight out or whatever. Yeah, spinning ball, like is it going that way? Is it going that way? You can, the thing that stays constant is kind of like sort of perpendicular to those directions. So it's considered to be perpendicular. And this will get the direction right and the magnitude right. We got the same thing with our angular momentum, cross product, the distance from the pivot times the momentum, because remember what matters is the momentum that is perpendicular to the radius going to the axis of rotation. So cross product. So we have a bunch of this stuff that's been here the whole time, and it's been bugging me that I haven't been teaching it to you, but since it doesn't come up on the exam, it wasn't a priority before. And notice also all this magnetic stuff. By the way, B is magnetic field. It's just full of cross product and dot product stuff. So I figured I better teach you that. Anyway, thanks for listening. Ooh.